Hi everyone, I am Jitender Maurya. I am going to present our work domain adaptation using self-training with Mixup for one-stage object detection. We propose a method to generate accurate pseudo labels through feature distribution alignment and periodic data distillation. And also we propose an end-to-end self-training method with interpolation-based consistency regularization called Mixup and confirm its validity in the context of domain adaptation. And lastly, we validate the proposed method on a one-stage detector and conduct extensive experiment and achieve comparable performance to the state-of-the-art method on the standard domain adaptation benchmark datasets such as clipart, watercolor, comic, and also Caltech dataset. Our method have two components: feature distribution alignment and self-training with Mixup. In feature distribution alignment, we align the feature at various convolution layers through adversarial training using domain classifier. Once the features of the sample space and the target space are aligned properly, we apply data distillation to have robust pseudo label. For this, we transform the images in various possible ways and then feed these to the model. Then we have a lot of bounding boxes for each object in the images, and it is highly likely that bounding box will concentrate around object which is assembled to have the final robust bounding boxes. These robust bounding boxes are used for self-training. Data distillation is performed after each epoch to define pseudo label. Now this pseudo label is used during the self-training. During the self-training, we choose a convolution layer randomly and perform mix-up. In mix-up, we add the features for two different objects and forward pass it to the next convolution layer. The same mix-up is applied to the class label also, and now this mixed class label is used as a ground truth. Now after with FDA and STM, we can see that features the model have improved discriminative capabilities on the target domain. Training is enabled only for some duration. With Mixup, it can be seen that the performance is highly consistent and it is highly effective. However, without Mixup, the performance slightly increases, then its performance degrades drastically. For our experiment, we have used Pascal VOC as a source dataset, and it can be seen that on clipart dataset we have outperformed the state-of-the-art method. Earlier the best MAP was 37.8. However, with our method we get the best MAP of 41.6. Similarly, for the comic 2K dataset also we have outperformed the state-of-the-art methods and by a significant margin, and similarly on the watercolor dataset also. To test the performance on the real world scenario, we choose the COCO dataset as a source dataset and Caltech dataset as a target datasets. Here this evaluation is done only on the person class, and it can be seen that our method has significantly improved the performance